Here's a solution to another one of the D2L problems. This is very similar to the problem we did in class where we were talking about forming a string of 3 letters in which at least one letter is repeated. And when we were doing the birthday problem, we were seeing how many strings of birthdays would go together in which at least one birthday is repeated. So those two examples are additional examples of the same thing. The key word here in this problem is this phrase, at least one of something, and when that happens, then the complementary problem is suggested and often will save you some trouble. So here we want at least one digit repeated, which means that I would want to think about the complementary problem which is how many, I'll just write HM, how many So the complementary problem here is how many of these 5-digit numbers have no repeated digits. If I made a list of all possible 5-digit numbers that only use these digits, some of them will have repeated digits and some of them won't. The ones I want to count here are the ones that have some repetition. The ones that I don't want are the ones that have no repetition, but I suggest that the complementary problem, the ones with no repetition, is actually easier to count. We count 5-digit numbers. These are ordered lists, so we write 5 blanks down. And so the total number of these, which I'm going to need in order to be able to do the complementary problem, by the total, I mean the number of 5-digit numbers without any additional condition. So by the total, I mean just this question: how many 5-digit numbers are there? And so I would do this in a 5-step process. I choose a number for the first blank, choose a number for the second blank, and so forth. And my choices in each of the 5 blanks can be any one of these 6 numbers. So I have 6 choices for each of the 5 blanks. And so the total is 6 times 6 times 6 5 times, which is 6 to the 5th power. So that's how many numbers I can form using 5 digits, and the digits having to come from these 6 numbers. So now I can get back to the actual condition. I want to find out how many of those have no repeated digits. Well, I'm using the same 5 blanks and the same idea, but now, if I'm not allowed to repeat, I have 6 choices for the first blank, 5 choices for the second blank, and so on. And so I'll have 4 choices for the third, 3 choices, 2 choices. So the total number of ways with no repetition is 6 times 5 times 4 times 3 times 2. One number for each of the blanks, and the numbers fall one at a time. So that's the number of the 6 to the 5th total have no repeats, is this number. So therefore, the number of these 6 to the 5th that have some repeats is just the subtraction, this is the difference between this total number and the number that have no repeats. And so if I subtract this number minus this number, that'll be the answer to the original question, the number of 5-digit numbers that have at least one repeated digit.